Hi everyone, my name is Richard. In today's video, I want to show you my Python project for this class. The project is about to write an AI program to solve a Sudoku game. Now, for someone who don't know about a Sudoku game, this is a very funny game with a grid of 9 rows, 9 columns, and 9 blocks. And we are required to fill in every row, every column, and every block, number 1 to 9, so that each number is unique in each row, each column, and each block. Now, if you search on the internet about program to solve a Sudoku game, you could find many resources about a backtracking algorithm, which is similar to a brute force algorithm, where we try every combination of numbers and choose the one that does not violate the game rule. My program does not use this idea. Instead, it leverages one of the field of artificial intelligence known as knowledge representation and reasoning. Now, if you go to my GitHub repo, you will see that I input a link to the web page describing what knowledge representation and reasoning is. And you can see that it is a field of artificial intelligence dedicated to representing information about the world in the form that a computer system can use to solve complex tasks. So you can figure out more information in this link. In short, my program represents the knowledge we know about how to solve the Sudoku game. And the difference between my program and the backtracking algorithm is that we can infer new knowledge based on the interaction of the knowledge in the knowledge base, and thus mimic the way a human being solves the Sudoku game, which also known as artificial intelligence. I have also noted some useful information in a readme.md file describing the function of this program and how you can run this program by yourself. Okay, now I will show you how it works. Okay, now I go to terminal and you can see that in this repo, there is a Python file called game.py. This is a graphical user interface program where you can interact with the game. So I run Python game.py, and here's the welcoming screen. To start, you can click Let's Go. And you can see here a random Sudoku game on the left. I have downloaded 9 million games. So you can try and play yourself with a pen and paper, a bunch of games here. Now, if you just want to see the AI playing, you can click AI play and yay, you will see the AI fills all the blank cell with green numbers. You see a violation showing here that indicating that this program fails to provide the correct answer. And you see the sorry showing here, that means that this program cannot solve the game. And what you are seeing here is yay, which means that the AI solved the program correctly. If you want to play a new game, you can click reset. And it will shuffle and produce another random game out of 9 million games from the source. And you can continue. If you want to see the AI play, you can click AI play. If you want another game, you can click reset button. And if you don't like it, you can click reset until you find a game that you really like, and you can click AI play, and yay. That's it. Really cool, huh? Okay, now what I want to show you next is the source code I wrote to build this AI. In this repo, you will find a file named sudoku.py. This file contains 3 objects. Actually 4 objects. Okay, the first one is a game violation, which inherits from exception. This is just a nice way for the code to be more readable. So whenever the AI inputs an invalid number, this exception will be raised. Nothing really fancy here. Okay, the 3 main objects of this program is Sudoku collection, the board, and the Sudoku AI. Let's take a look at each one. So the 9 million game file I downloaded is pretty heavy and slow to process. That's why I put them into a database, and I use SQL so we can query the game. So the Sudoku collection represents the way we interact with that database. You can see the very basic attribute and function to interact with the database with Python, such as connect, cursor, execute, commit, create table, delete, so on and so forth. So there is one thing I want to show you here about this class. When I built this program, I need to test it with different level of Sudoku game. But in this game source, I don't have that information. That's why I use a very intuitive way to classify the difficulty of game that is based on the number of blank cells in the game. And I did some analysis to choose some threshold. So you can see here that 25% of the games having more or equal to 47 blank cells, which are classified as hard. 50% of the game having more or equal to 39 blank cells, and less than 47 are classified as medium, and the rest 25% are easy. This is just an intuitive way for me to debug my code, and this is not showing the real level of difficulty of this game, okay? Okay, now let's get to the next object, which is the board. This is a representation of the game with 9 rows, 9 columns, and 9 blocks. So this class takes input a puzzle as the puzzle and a solution as the solution to that puzzle. I also have one class attribute named given cells. So I can distinguish which cell is given in the beginning of the game and which cell is filled by the AI. So the board has some function of a board. Okay, they can check whether or not the game is solved or not. It's checking if the game solved is the same as the solution provided. If the board finds a violation where the AI input the number to a cell, it will raise a game violation. You can see the game violation exception here. It also has a function to print out the board to the terminal, which is very useful, and I will show you guys later in the video. It's an update function which receives information from the AI to update the board itself. And the last one adjusts the get method to safely access the class attributes. Okay, so the last one is the class Sudoku AI, which is the most important part of this program. Right? So you can see here that this class takes input as a Sudoku puzzle, and it does not know the solution. Therefore, this is a separate entity from the board, and the only way to get to the solution of this puzzle is to do reasoning and inference and interaction with the board. I want to show you the way I represent the knowledge. I have an attribute named self-acknowledges, which is our knowledge base. This is a dictionary with key as tuple of row column representing the cell, and value is the set of possible numbers that can be filled in that cell. There are 2 reasons I use set as a value. One is to ensure that there is no duplicate number as possible candidates to fill the cell. And 2 is to use many useful built-in set function in Python, such as different, union, and intersection. I also have another attribute called self-known. This is a dictionary with the same format as the self-acknowledges. If we know exactly which number to be filled in a cell, it will be in self-known and not in self-acknowledges. I also have a set of send to keep track of what we have already sent to the board, and set up blocks is to do some calculation faster when we let the knowledge interact with each other. Okay. So the Sudoku AI class has some fundamental functions. First is the fill. This method will send information to the board. We have known cell. So the logic here is that whenever at a position, we only have one possible value. That value is a solution to that cell. So this function returns true if we can conclude that cell and false otherwise. We have remove numbers, which is to remove the invalid candidate that are no longer potential candidates to fill the cell. The next one is the main coordination of this AI program, the infer knowledge method. Within this method, we are calling many other methods, which are to let the knowledge in the knowledge base interact with each other in some specific strategic way. So the main action of solving a Sudoku game is to eliminate as many invalid candidates to fill a cell as possible, so that when we have only one candidate left, that candidate is solution to that cell. For example, the game group tells us that only one number from 1 to 9 can only be present in a row. So if a row already has a number, we can safely eliminate that number in the knowledge base of the cells in the same row. Another thing I want to highlight here is that the knowledge base not only interacts with the known cells, but also with each other to infer new knowledge. For example, the naked pair strategy. The naked pair strategy tells us that if a pair of candidates exist only in a row, then they are the solution to that pair of cells, and all other cells in the same row can eliminate that pair of candidates. So you can see that in this infer knowledge methods, there's a bunch of other methods to let the knowledge interact with each other and infer new knowledge. One trade-off I made here, I want to notice is that you can see I have a while loop here with a tracker variable to keep track the number of times we loop through this strategy. This is because as a real Sudoku solver, we do not use only one strategy, but multiple strategies at different order to solve the puzzle. Let's say I have a puzzle that can be solved if I use naked pair and then X-wings. Then the other puzzle I can only solve if I use X-wing and then naked pair. So it's not possible for us to make a linear way of ordering which strategy should be called first and second and third and so on. That's why I have to make a while loop here to ensure that every strategy can interact with other strategy at least once to solve the puzzle. So here I trade time for the number of puzzles that we can solve. And so far, the time this program needs to solve one puzzle is still within a second. So I don't think it's a big problem. So the next one are just the implementation of strategy to solve a game, which I won't go into the detail. You can check it out with the doc string I add here and the code I wrote. Okay, so the last one, just some helper function to check if the cells are in the same row, same column, or same block. And that's pretty much about the object of this program. The next thing I want to show you is the GUI program that you see at the beginning of this video. I think it's pretty straightforward because like most of the code are just to build the user interface by using the Pygame package. Instead, I want to notice two things in this program. First is that you can control the speed of this AI program. So far, this program can solve 99.5% out of 9 million games, and each game is solved within 1 second. So it may be too fast for us to see what's actually happening. So you can change the time here in the sleep time variable. And you can see here that after each loop of inferring a number to itself, the program will sleep for a sleep time seconds. So I recommend that you can change the sleep to 0.1 or 0.2 only. The thing is that this program has to bring a lot of things to the GUI. So you may think that sleep for 0.1 second is really slow, but actually it also takes into account the amount of printing things to the GUI. So it's slower than it is. So I can show you very quickly. For example, I change the sleep time to 0.2, and now I rerun the program. Yeah, and you can see that it's slower, right? Yay, we solved the game. So that's my recommendation, but I leave it up to you to modify the speed of the program on your own. The second thing I want to show you here is how the object you see in the Sudoku.py interact with each other. So here you can see that whenever the AI can continue to solve the puzzle, we set a new number to the cell. Then the chart on the board is to check whether the game is solved correctly or not. And if there is a violation, it will raise an exception, else it will update the value of that cell. All right, so it's pretty straightforward here, and you can get into my repo and check these codes out. The last thing I want to show is I have already written 2 more programs for you to investigate and test this program. So as I mentioned previously, you can also see this program running right in the terminal. If you go into the file run.py, you can see my implementation for that. What I will do here is to quickly show you how it runs in the terminal, okay? So I go into the terminal and type Python run.py, and it will ask you to input a game ID from 1 to 9 million. So if you input something that is out of the range, it will say that, okay, game ID out of range. And if you input some ID that is within the range, and it will run a puzzle and the result of the AI play, and yeah, congratulations, I saw the good game. I can repeat the process many times as you want, okay? Cool, all right. So the last thing is the test.py file. Let's say you have a bunch of Sudoku games and you want to check how many games can be solved or the speed of solving the game. Then you can use the test.py program. Here I am calling all 9 million games, but you can change it. For example, you have a text file containing 100 puzzle ID. Then within the terminal, you can cat the text file and pipe it with a test.py. But I will not do it now. Instead, I will show you how this test.py runs. I go into the terminal again and I type Python test.py. So you can see a pause here, right? This is because the program is trying to pull all 9 million games from the database, so it takes a while. But once it's done getting the game, then you can see that it can very quickly solve a bunch of games within a second. Okay. All right, so that's pretty much all about my AI program. So you can freely check it out in this repo, and you can contact me if you have any questions. And that's it. Thanks so much for watching.